Hello everyone, welcome to Civil Engineering and Stuff. And today's topic of discussion is history of pavement construction. In today's video, we are going to learn about the historical benchmark in the construction that led to the design of pavement as we see today. So make sure you watch the video till the end. And if you find the video useful and feel that it serves your desired purpose, consider liking the video and post your views in the comment section. Also consider subscribing to the channel for more videos related to civil engineering. Alright, so let us discuss various benchmarks in the history of pavement construction. So in this, the first one is the Roman roads. The roads that were constructed during the Roman Empire was so strong and durable that many of the pavements still exist in today's time. Now, the road constructed by Romans involved the curved stone placed at the edge of the pavement, and the soft soil was excavated till to the point hard rock strata is reached. And once the hard rock strata is reached, over that large foundation stones were placed, and the depth normally varied from 10 to 20 centimeters. And above a large foundation stone, another layer of lime mortar was placed. The depth of this lime mortar layer varied from 25 to 40 centimeters. And then again, over this lime mortar layer, big stones were placed. The depth varied from 10 to 15 centimeters, and basically this layer acted as a surface layer over which the movement of traffic was carried out. On and all, the overall depth of the roads created by the Romans varied from 0.7 to 1.2 meters, and the width varied from 2.2 meters to 2.5 meters. Few points to be noted in the Roman roads was that there was no gradient or no cross slope provided, right? So the roads were constructed totally flat, and there was no provision of drainage in the roads that were constructed by the Romans. Apart from that, at that time, mostly the bullock carts or the animal carts were used as the major mode of transportation. So in that time, also to be noted, one more thing to be noted is that there were no automatic machineries at that time. So all this placement of large foundation stones, these large surface stones, were done by hand. So on and all, this construction with respect to the amount of load that this pavement is going to carry was not proportionate. The road were way too safe compared to the load that the road is going to take up, right? So this was like some of the constraints that were attached to the Roman roads, right? So as we have discussed, the Roman roads were strong and durable, and they were built straight regardless of any gradient. The soft soil was excavated till hard stratum is reached, and the thickness varied from 0.75 to 1.2 meters. Okay, and this was like way too much compared to the magnitude of the wheel load drawn by the animals at that time, right? So, talking about the positive aspect of the Roman roads, the first positive thing about Roman road was that this was at that time was the first pattern of construction in which the construction was done in layers. So we had for bottom layer had large foundation stones, and above that lime mortar, and above that again big stones that were put at the top surface. Curb stones were first provided in the Roman roads that provided some lateral stability to the overall pavement. The negative or the drawback related to Roman roads were that first of all there was no drainage system, and the second is there was no cross slope provided. And the third negative point was that basically they used large foundation stone at the bottom. Okay, so these were some of the limitations attached to the Roman roads. Now these are some of the peaks that we are going to see of the Roman roads that still exist in today's time, and you can see the large stones placed at the surface, and the road is like there's no cross slope provided at the surface, and there's no drainage facility provided in the roads, right? So again here another Roman roads we can see large foundation stones totally flat, and there's no drainage facility here. The next benchmark in the pavement construction was by the road designed by Piers Trescott. So Piers Trescott, in his construction method, improved the overall way in which the road has to be constructed, and basically all the drawbacks or the limitations that were there in the Roman roads were covered in this Trescott method of road construction. So there were certain important points or the main features that were attached to this construction method. The first one was that the thickness of the pavement was restricted to 30 centimeter only. Whereas if we see in the Roman roads, only the foundation covered that much amount of thickness, right? The overall thickness varied from zero point 0.7 to 1.2 meters, right? While in Truscott method of construction, the thickness restricted to only 30 centimeters. And this construction method that was proposed by Piers Truscott gave due consideration to the subgrade moisture conditions. So a proper assessment of how much moisture is required in the subgrade was done, and the provision of drainage was also provided in this construction method. Now in this subgrade was prepared, and large foundation stones were laid on edge by the hand that act as a curb stone. So these type of uh, pavement still included curb stones, but the also included a well compacted and properly assessed moisture content containing subgrade. The broken stone packed to a thickness of 8 centimeter and then again compacted, and the top bearing cores were again made up of small stone made up of smaller stones and compacted to 5 centimeter thickness. So proper compaction of each layer was done. Large foundation stones were used, large stones were used, and then above that comparatively smaller stones were used. Now these large stones that were used in this Truscott method, the voids were also filled by the smaller stone particles. Apart from that, another main feature was that the cross slope was provided. The cross slope of 1 in 45 was provided for the surface drainage, which leads to the next main feature, that there was a provision of surface drainage. And then shoulders were also provided to drain the surface water to the side drain. So on and all, the positive thing about this method of construction was that there was a drainage system and there was the cross slope provided for this layer, for this method of construction. However, this construction method also had certain limitations. The limitation was the first limitation was that the cross slope was provided only at the top layer, while the bottom layer doesn't had the provision of cross slope. They were again constructed flat, and large stones were provided at the bottom. So this again used large foundation stones as the base, and above that the layer was constructed. All right. So the Truscott method of construction, the thickness was limited to 30 centimeter only, and at the edge we had the curb stone, and then at the bottom large foundation stones were provided, whose thickness varied to 17 centimeter, and the voids were filled by small broken stones. And above the large foundation stone, another layer of broken stones was provided, the thickness of which was around 8 centimeters. And above that, a layer of lime concrete was provided, whose thickness was around 5 centimeters. And that lime concrete layer, that is the surface layer, had the cross slope, right? While other two layers were laid flat. You can see there's no cross slope in the bottom two layers. The cross slope was only provided at the surface layer, and which led to provision of drainage system as well as the provision of having shoulders in the pavement. So overall, this was how the cross section of Trusgate method of construction looked like. The width of road was 2.7 meters. Now, the limitations that were there in the Trusgate method, that is, first of all, still it used large foundation stones and there was no cross slope provided in the bottom layers. So these limitations were then again covered in the construction method proposed by the Thomas Telford. So Thomas Telford was the founder of Institute of Civil Engineering at London, and the road construction method that he proposed was known as the Telford method. Now, the main feature of Telford method was that first of all, the subgrade width was around 9 meters, and the large foundation stones, though again this method used the large foundation stone, but the the overall size of stone varied from 17 to 22 centimeters, while the previous methods only used the foundation stone of same dimension, right, of same size. Here in the foundation, two different size of stones were used, 17 centimeters and 22 centimeter. So the stones that were of lesser size, that is 17 centimeter, were placed toward the edge, and stones of higher dimensions were used toward the center. Now the benefit of using these varying dimension is that cross slope was provided at the right from the foundation level. Another important feature of this method of construction was that on and all it was a well compacted structure. So each layer was very well compacted. The voids that were there in between the foundation stone were filled by smaller broken stones, and the central portion was constructed in two layers. That was prepared with angular broken stones, and the thickness of the layer was 10 centimeter and 5 centimeter respectively. And the previous method used curved stone. Here, instead of curved stone, the edge portion was constructed by the compacted broken stone in lime mortar instead of the curved stones. And 4 centimeter thick gravel was laid on the top with the cross slope of 1 in 45, and the provision of drainage was provided here, so this was a continuation of the advantage that was of the previous method. So on and all, the positive thing about this method was that cross slope was provided in all layers, while in the previous method only the top surface had the cross slope provision. So there was because of providing cross slope in all the layers, we had a uniform load distribution or transformation, and a drainage system was provided. The negative was again, though varying dimension of large stones were used, but still large foundation stones were used in this method. So above hard rock strata, we had varying depth of large foundation stones. Uh, at the edge, we had smaller stone particles of dimension 17 centimeter, and at the center part, we had large foundation stone of 22 centimeters. And above that, we had well compacted lime mortar, which was replacing the curved stones. And then we had the layers made up of broken stone whose dimension was 5 centimeter, and at the top we had a layer of varying course prepared by the broken stones. And as we can see, the cross slope was provided in all the three layers, and the drainage facility was continued in this construction method. The width was around 4.5 meters for this Telford method of construction. After this, the next benchmark in the pavement construction was the construction method proposed by John Macadam. Now, John Macadam was the Surveyor General of Road in England, and basically the construction method that was proposed by John Macadam, which is the Macadam method of construction. This was the first method that was prepared with the scientific thinking, and this method is somewhat still used in today's time, right? So basically, here proper due consideration was given for each layers. A total scientific thinking was implemented for the development of this construction method. So here the main feature of macadam method of construction was that first of all, uh, it was assessed that there is no need for large foundation stones. A proper well compacted subgrade will serve the purpose. There was no need of using large foundation stone. So here the well compacted subgrade was provided with a cross slope of 1 in 36. John Macadam was the first engineer to suggest that there was no need for heavy foundation stones. And of using large foundation stone, we can construct the pavement in number of layers, and each layer contains a variety of stone mixed together so that it forms a well compacted structure, right? So instead of large foundation stone, each layer was in each layer smaller stones were used in a specific proportion, like specific dimension of stones to be used in each layer were proposed and were well compacted to prepare a whole of the pavement. This lead to reduction in the total thickness of the pavement. Size of broken stones to be used in the top layer was decided based on the stability of pavement under the action of animal drawn vehicles, right? So based upon the type of loading that the pavement is going to face, the dimension and the thickness of the layers of the pavement were decided. So all in all, proper scientific thinking was done for the construction of this type of pavement, and cross slope of 1 in 36 were provided for the water drainage. So the positive points regarding the macadam method of construction was that large stones replaced by smaller broken stones. So the construction was much easier and much faster, and due emphasis was given for each layer, and what kind of material to be used and what amount of compaction has to be done, everything was well defined. So this was the first method that used the scientific approach for the pavement construction. So this macadam method of construction involved the use of curbstone at the edge. So it again brought back the use of curbstone so as to provide the lateral stability. And at the bottom, we had a well compacted soil subgrade. Above that, we had a layer of subbase course, that is GSB course, whose thickness was around 10 centimeter, and this layer was made with the aggregate that were passing 5 centimeter sieve. Above that, we had another layer. The layer was called as the base course layer of WMM. The thickness of this layer was around 10 centimeter, and the aggregate that were used were 3.75 centimeter passing broken stones. And at the top we had the surface course of BC layer. The thickness was around 5 centimeter, made with the aggregate that were passing 1.9 centimeter sieve. And then a provision of drainage was provided along with this construction method, right? So on and all, due consideration was given for each layer, what kind of aggregate to be used, what amount of compaction should be given. So the construction method became much more easier, much more durable with respect to the type of loading that the pavement is going to suffer. All right. So this was the macadam method of construction, and this method is still being used in today's time for construction of pavement, right? So at the end, one thing that we should know is that as we go from top to bottom, as we go from different layers from top to bottom, the stiffness of the material decreases, right? So the top layer will have higher stiffness, and as we go down, the stiffness of the material will decrease. All right. So this was all about the construction of pavement. If you find this video was useful, then like I said at the starting of the video, please press the like button and share your views in the comment section. Consider subscribing to the channel and pressing the bell icon for regular notification. So that's it for today. Thank you for watching. Have a nice day.